All right, this is like an introduction to transformations of quadratic functions, okay? Transformations are all about how things move, okay? How things move, basically about the graph, okay? Does it reflect? Does it shift left or right, up or down? Does it get stretched or compressed? All that stuff is a transformation, okay? And what we're going to do today is look at all about y equals x squared. This is what's called the parent function, okay? So we refer to this as the parent function of a quadratic. So parent function. Okay? The parent function of a quadratic. And that's why all these graphs, the top one up here to the top right and all these three up below, they all have y equals x squared graphed. Okay? And so what we're going to do is we're going to graph the new functions on each of these graphs and see how it transformed or how it translated. Okay? And we're always going to... well, not always, but for now, we're going to look at the vertex form of an equation, which you've guys seen it before, is y equals a times x minus h squared plus k. Okay. All right. So you have learned this before. A, h, and k all stand for some integers, okay, either negative or positive, all right? And then this description here, the hk and the a, describe what happens to the parent function when you start adding these numbers in there, okay? So if you have an h, if there's a number in the h spot, think of the h standing for horizontal, the horizontal axis, okay, or the x-axis. So that has to deal with left or right, okay? And the only thing that's really hard about this, seeing translations, is figuring out, okay, it moves horizontally, but is it left or right? Okay, you do have to figure out, you have to pay close attention to if it moves left, okay, that means that the x is added, okay, or there's a plus h here. I'm sorry, the h is added, there's a plus h, okay? You have to do the opposite sign, okay? Just like when you found the vertex, it's the opposite of h, comma k, okay? So if this is a minus 4, then it would move 4 units right, not left, okay? So right is in the positive direction, left is in the negative direction, but you have to change the opposite sign, okay? So if h is subtracted, then you move to the right. If h is added, you move to the left, okay? And now the k, the number that's not in parentheses. Now, I wish that they just used a v here, but they don't. Okay, so k, I don't really have a word that stands for k, but k is not the h, so it moves the other axis, which is the vertical axis. Okay, so k moves either up or down. Okay, vertical axis. And this one is the easiest one out of all the translations or transformations. If k is positive, it moves in the positive direction, which is up. If k is negative, then it moves in the negative direction, which is down. And the reflection, okay? So if a, that number that is outside the parentheses, all right, so there's two things that can happen if it is a negative or a positive, okay? If it's positive, you don't have to state any kind of transformation because it just stays pointing up, okay? Because the parent function already points up, so there's nothing that changed as far as if it moved reflected or not. But if it is negative, if there's a negative in front of the a, that means that the graph flipped over, or what's called reflected across the x-axis. Okay, so that's what you might want to put here, okay? Put across x-axis. Across x-axis, okay? There we go. All right, and then now the other thing that A has to deal with is, does this graph stretch or does it compress? Okay, so think about yourself standing up, and if you were to stretch your arms up high, that means you are getting bigger or taller. So that means that the graph is stretching, or it's getting taller, it's getting skinnier. Okay, and one thing I do want to change here is I want to put absolute value around this A. Okay, the absolute value of A. All right, because I want you to get in the habit of, it doesn't matter if it's negative or positive, because the negative or positive deals with the reflection or not, okay? But once you get the reflection, don't worry about the negative, just worry about the number, the absolute value of the number. If it's greater than 1, that means it's a bigger number, so it's stretching vertically, okay? So stretching. All right, and then if A is a fraction or less than 1, in between 0 and 1, like 1/2, 1/3, something like that, that means it's compressing, or it's getting fatter or smaller. Okay. All right, so let's go through an example or two. All right, so one thing that might be beneficial just to get started is to graph the new function on your function or on your graph that already has the parent function, okay? I already went through and graphed it. You can easily grab a calculator and graph these and get a table, or what you can do is just plug in values, okay? So I'm just going to speed this up a little bit. You should have a point at 3,7, okay? So 1, 2, 3, and this graph is kind of hard to see, so let's go on the y-axis and count 1, 2, 3, 4, 5, 6, 7, and go ahead and put a dot at 3,7. It doesn't have to be exact, just give me kind of more of an estimate since the graph doesn't have grid lines. All right, then there should be a point at 1, 2, 3, 4, comma 1, 2, 3, 4. So it should be a graph at, is that right? 1, 2, 3, 4. And then 1, 2, 3, 4. I think it should be 4, comma 5. So 1, 2, 3, 4. 1, 2, 3, 4, and 5. About right there. The new vertex is going to be at 5, comma 2. So 1, 2, 3, 4, 5, comma 1, 2, about right there. All right, and then the next one will be, and I'm going to change this. I think this is supposed to be at 4, comma 4 or 4, comma 3. So I don't have my calculator with me, but that's fine right there. All right, and then another graph is at 6, comma, the same coordinate of the y, about 3 or 4. I can't remember which one it is, right there. And then the next one is going to be at 7, comma 7. 7, comma 7, just like that. Okay, so your new parabola looks like this. So you can see, hopefully you can see that it didn't get any wider or skinnier, but it did shift. It moved somewhere, okay? And notice how there is no number. There's no number in the A spot. So that means there's nothing to do with reflection or compression or stretching, nothing like that. And if you guys recall, we did review how to go over the vertex. It's the opposite of H, that's positive 5, and then whatever K is, and that's positive 3. So that's your vertex. Axis symmetry, real easy. X equals that X coordinate, which is 5. All right, and then next is going to be what happened for the transformation, okay? So I want you, we're going to try to do the transformation just looking at the equation, and then we are going to look at the graph and see if that actually was a transformation, okay? So let's go up here. What does H mean, all right? And what number's in front of H? Well, that is your -5, okay? So you're -5 here. And so for right now, let's go ahead and look and go get our cheat sheet here, our horizontal translation here. All right, so that -5. If it's a subtracting 5, that is the second box here. Right here, it means it's moving right, or the opposite of negative direction, and we're going to go positive direction. Remember, H stands for horizontal, so horizontal axis, so that is going to move, or shift, we'll say shift 5 units right, okay? So remember, right and left is horizontal, or the H, okay? All right, and then now we got to take care of this 3, okay? So let's go ahead and go up with, that means the K, right? H is the number with the X, and K is the number outside the parentheses, added or subtracted, okay? If K is positive, it moves up. If K is negative, it moves down. So K is positive here, so it shifts. So I'm going to put an and here, so and 3 units up, okay? And for this particular one, that's all we do from the equation, all right? So now let's go back to our graph. We said it shifted 5 units right and 3 units up. And when you say shift, that just means the vertex, okay? So see how the vertex is here from the, let me do a different color. Vertex is here for the parent function. And now the vertex is shifted over here at 5, comma 3, okay? So 5, comma 3. All right. Oh, that reminds me. So these ones here are going to be 4, comma 4 and 6, comma 4 right there. So I apologize about that earlier. Okay. So then do the vertex. Where did it shift? Well, you can see how it shifted over 1, 2, 3, 4, 5 to the right, and then up 1, 2, 3. Okay. And once again, I apologize for the no grid lines, but that's okay. We just need kind of an estimate. So you can see how it did shift 5 units right and 3 units up, okay? Or in other words, whatever the vertex is. So whatever your vertex is, that's basically the shifts. This is your horizontal shifts, and the 3 is your vertical shifts, up or down, okay? So that's another thing that might make this simpler is, what is the vertex? Okay, there's my shifts right there. 5 units horizontally, 3 units vertically, okay? All right, let's go to one more, and we're gonna graph this one. This one has a negative sign, okay? So that means that it is gonna be reflected, but let's go ahead and graph this first. So once again, if you grab your calculators, that might make it easier. You can just choose points and plug those in as well, okay? So the points that I got were, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So I got a 2, -8. So I got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, about right there. And then I got another point at 3, -2, 3, -2. And then I got a point at 4, 0. That's the vertex. And then we're just going to mirror the same point. So the next one's going to be 5, -2. And then 6, -8. Okay? Go ahead and draw this. All right. And once again, you can punch this in your calculator, get a table. That makes it easier, but you can always make your own table and plug in values and find it from there. Okay? All right, so we're going to come back to the graph. So for right now, let's go ahead and label our vertex and axis of symmetry just from looking at the equation. Okay? The vertex is h, k. So let me remind you of that. Got h, k. And sometimes I like to remind you guys of saying the negative h or opposite of h. Okay? So your vertex is going to be opposite of the h, which is going to be +4. And since there is no number added or subtracted outside the parentheses, that's going to be 0. 4, 0. Okay? Another number for nothing, and number for nothing is 0. Okay, so if there's nothing out there, it's 0. So x equals the axis of symmetry, whatever the x coordinate is, it's 4. X equals 4. All right, so now let's look at the transformations, okay? So first, let's work from left to right, okay? So the very left after the equal sign is you have a negative sign here. All right, so what does a negative sign mean? All right, well, up here on the reflection, remember, the negative always has to deal with the A. So the reflection down, if A is negative, okay, so we know we have a reflection, all right? But what I do want you to get in the habit of saying reflection across the x-axis. So reflection across x-axis. Okay, it takes care of the negative sign. That should be the easiest thing for you guys to figure out. All right, then we have this 2. All right, then we have a 2. All right, so let's go back up to our A description. All right, we already took care of the top box. Now the bottom box says if absolute value of A is greater than 1, all right, the absolute value of -2 is +2, so that is going to be greater than 1, so that is a stretch right here, because 2 is bigger than 1, so it's a vertical stretch. Or think about 2 being bigger. Okay, 2 is a bigger number than 1, so that means it's getting bigger or stretching. Okay, so we have a vertical stretch. All right, and one thing I did not mention earlier, we have to say by a factor of some number. So by a factor, and then whatever number that is, which is 2. So by a factor of 2. By a factor, oops, sorry, I should say of 2. By a factor of 2. There we go. Okay. All right. There we go. So now let's take care of the h and the k. Okay. The h here is going to be -4. Okay, or -4. So what does -4 mean? If you want a cheat sheet, go back up here to your h. Remember, inside the parentheses or horizontal shift left to right. It says a -4, so that means that it moves left if h is added. Okay, well, it's not added, it's subtracted, so it moves right if a is subtracted. All right, so since h is subtracted, not a, since h is subtracted, it's going to move right. Okay, so we got 4, so shifted. So it shifts 4 units right. 4 units right. Okay. All right. And since there is nothing, you can, if you want, you don't have to, you can think of it as being a +0. Okay. There is no shift. There's 0. Think about the 0 vertical shift. The K is 0, so there is no shift vertically. Okay. All right. I'm going to let you guys figure out the last one on your own. This is a 1/2. So yeah, because I'm running out of time. So this is a 1/2. That means that it's going to be a compression. This +6 means it's going to move left, and this -3 means it's going to move down. Okay, and there is no negative so there's no reflection. All right.